So first they just are having us review SOHCAHTOA, how to solve for those missing sides and angles. So first of all, if I'm trying to find sine of x or sine of theta, what ratio am I setting up? Good. Alright, what is my ratio for cosine? Good. And what's our ratio for tangents? Good. Okay, so we're going to do a quick problem using these ratios to help us find missing sides and angles. So they gave us this figure here. We're going to go in and label a few pieces. So this angle up here at the top, it's going to measure 55 degrees. Okay. Obviously, this is our right angle. Okay. And this angle is unknown. So I'm going to say it's x degrees down here. Okay. All right. Our hypotenuse is going to measure 12. And this bottom leg is going to measure 9.8. Okay. And we don't know this side. We're going to call it C. Okay, so when we are working this problem, we are going to solve for both x and z using trig ratios. Okay, so let's find that missing angle x first. Here's our angle with the x in it. Okay, whenever we're solving a problem, we can only have one variable in it at a time, right? So whichever sides I use have to be sides that I have a real number value for. I can't use z right now, and I'm also trying to find x. So the two sides that we do know, what sides are they in relation to that angle? All right, adjacent and hypotenuse. So what ratio am I going to have to use? Cosine, right? That's the only one that uses those two sides. So, to find x, we'll have cosine of x degrees is equal to adjacent. What's our adjacent? Good. Over hypotenuse, which is good. All right. And I'm trying to solve for that missing angle. What do we do to solve for our missing angles? Right, we take the inverse. Very good. So x degrees is equal to our inverse for cosine of 9.8 over 12. Okay? Now, before you type that in your calculator, double check, make sure you are in degrees. Okay? And about how many degrees is angle x? 35 degrees. Very good. So x is equal to 35 degrees. Alright, so we solved for the first one. Now we've got to solve for z. Okay? Alright, so now I do know that this is 35 degrees. So I know both angles. So which angle would you guys prefer to use? The 55 or the 35? 55. Okay, so I'm looking at this angle. If that's my angle, what is z in reference to that angle? Adjacent, right? Okay, so I know I'm using the 55 for the angle, and I have to use adjacent, right? So that would mean I could pick. Do I want to use cosine or tangent, right? Because I know both the hypotenuse and the opposite side. So which one would you guys prefer to use, cosine or tangent? Cosine? All right, so we would have cosine of the angle you guys said you want to use, which is 55, is equal to adjacent, which is z, good, over the hypotenuse, which is very good. All right, so how am I going to get rid of that divide by 12? Multiply, good. All right, so I have 12 times cosine of 55 is equal to z. So approximately how long is z? Approximately 6.9 if we round up, right? So there is my length for z. Good. Okay, so quick refresher there. Now we're going to introduce those two terms that you saw a couple of problems on not yesterday. I saw you guys 2 days ago on that assignment that mentioned elevation and depression angles. So we're going to start first with angles of elevation. Okay. Your angle of elevation is going to occur if you look up at an object the angle between your line of sight and the ground. Is what we refer to as the angle of elevation. Okay. So then they give us a little figure over here for us to draw on so that we can have a visual representation of what this would look like. Okay. So it's saying that you are standing over here. Usually if you are standing somewhere, it is on the ground. So here's you over here. Okay, and it says you're looking up at some object. So something in the sky. Maybe you're looking at the sun. We're going to go with the sun because I tried to draw a plane last period and we couldn't tell it was a plane. Okay, so we are looking up here at the sun. Okay. This is your line of sight, right? That is the line you are looking up on to see the sun. So this is what we call line of sight. Okay? And the ground is some horizontal line, right? So even if you were standing up on a platform of some sort, you still need it to be some horizontal line. So it's got to go straight across. Okay? And the angle that is formed by those two lines, your line of sight and your horizontal line, is right here. Right? And that is what we call the angle of elevation. So usually your angle of elevation is just going to be said to be in reference with the ground. Right? It starts at the ground, goes up. Okay? Makes sense. Elevation does mean up, right? To increase. Okay? All right. So let's look at some example that mentions an angle of elevation. So it says you want to build a skateboard ramp with a piece of plywood that is 14 feet long. To make sure that the skateboard can smoothly transition onto the ramp, you need the angle of elevation to be 26 degrees. They want to know, first of all, how high off the ground the ramp will be, and second of all, what will the horizontal length be? Okay, well, first of all, they said that the ramp was going to be how long? 14 feet, right? And if this is the drawing here, this is the part that's 14 feet, right? That's the actual ramp part that they would be skating on. Okay? So it was going up here, and there's my horizontal line. So the angle formed here must be the angle of elevation, right? And how many degrees did they say that angle was? Okay, so I got 26 degrees at this angle. Obviously, this is our 90-degree angle right here in this corner, right? So we know this angle's 26, this angle's 90, that one's 14, and then they asked us for two things. How high off the ground you're going to be. Well, which one of these two sides would measure the height? The vertical one. We'll call that x. And then how long the ramp will be would be the bottom, right? Okay. So we just need to solve for x and y. And we do have enough information to do that because we have an angle and one side. Okay. So let's start with x, which is representing the height. I'm going to find height first. Okay, so the angle that we have is the 26, right? If I'm looking at that 26-degree angle, what is x in reference to it? Opposite. And which side do we know? Hypotenuse. So we got opposite and hypotenuse. We must have to use good. So I have sine of my 26-degree angle is equal to opposite, good, over 14. Very good. All right, so if I want to solve for x, what should we do? Very good. All right, so 14 times sine of 26 is equal to x. So x is approximately, okay. And this is in terms of feet, right? All right, so we found height. Now we just need to find the horizontal length. Okay, so still using that same angle 26, what is y in reference to that angle? Adjacent. And we still have hypotenuse, so which ratio should we use? Good. So cosine of that 26-degree angle equals adjacent over hypotenuse. So again, I'm just trying to get that variable by itself. What are we going to do? Supposed to divide out. You got 14 times cosine of 26. And what do we get there? Good. Again, this is in feet. So, it doesn't really change the problem, but they'll explain it to you typically as a word problem, and you have to go in and label the sides. Okay. All right. So, our big takeaway from the front page, or our summary that we're going to write here at the bottom, is an angle of elevation starts on a horizontal line and rises to an object along a line of sight. Okay. Okay. Once you guys have that written down, if you will flip it over onto the back, we're going to talk about angles of depression. Okay, everybody have that before I flip over? Yeah. All right, so it says angle of depression. Okay, this is if you look down. At an object. it's going to be the angle between your line of sight and a horizontal line. Okay, so again, they give us a little figure over here so that we can draw on it, see exactly what they're talking about. Okay, so if you're looking down at something, you've got to be up above it, right? So you would be up here. So maybe you're standing on like some sort of a platform or something, okay? You are looking down at some object down here, okay? We'll go with a flower. Maybe I can draw that. Okay. So you are looking down at this object on the ground, and this is your horizontal line, right? So here is our horizontal line, and here is your line of sight. Okay. What's a little bit different about your angle of depression from your angle of elevation is that in elevation, your horizontal line was the ground, right? Like it actually exists. This line may not technically exist, it's just a reference point so that you can still have that 90-degree angle. Okay. All right, so it is the angle formed by that horizontal line and your line of sight, which would be right in here. So there is our angle of depression. Okay. All right, so now we're going to look at an example where they give us an angle of depression in the word problem. It says you are skiing on a mountain with an altitude of 12,550 feet. If your angle of depression is 21 degrees, about how far will you have to ski to meet your parents for lunch at the bottom of the mountain? Okay, so this little line they drew for us here is the slope, okay? If you're skiing down to meet your parents, you must currently be up here at the top, right? Okay, you're skiing down here to meet them, okay? So if you're up at the top and you are looking down on them, here is your line of sight, right? Like I said, your horizontal line probably does not technically exist, right? So it's just something out here. So that we have that 90-degree angle. Okay, so they said that this mountain has an altitude of 12,550 feet. So where would I put that on this figure that we've drawn? All right, this vertical line over here is representing height or altitude. Good. Remember, your altitude should form a 90-degree angle, right? Okay. It says your angle of depression is 21 degrees. So remember, your angle of depression is between your line of sight and the horizontal line, which would be right in here. Okay. And they want to know how far you're going to have to ski to meet your parents. So which line would that be? Very good. Okay. So we know our angle is 21. We know this side over here, we're looking for hypotenuse. Well, in reference to the angle of 21 degrees, where is that 12,550? Opposite. So we got opposite, we got hypotenuse, we must need to use A. So we got sine of our angle equals opposite over hypotenuse. Okay, so what would my first step be in solving here? Multiply by x, good. Alright, and then how am I going to get x by itself? How am I going to get x by itself, guys? Good. So x equals that 12,550 divided by sine of 21. So about how far are they going to need to ski? What'd you say? 35,019.9. Did you use the chart or did you use sine of 21? That's probably what. The chart rounds to 4 decimal places. If you just type in sine of 21, it doesn't round to 4 decimal places, so it will, especially since this is such big numbers, make more of a difference. Okay. Okay. All right. So now we've looked at an example with both elevation and depression. They want to know what's the relationship between the two. So what do they both have to have? A horizontal line. Very good. Okay. Okay. And then it's just your line of sight from that point, right? So they both have this horizontal line. This one would be looking up, so this would be our angle of elevation, while this angle would be somebody looking down, so angle of depression. Okay, so like you said, they do both have horizontal lines, right? If these two lines are horizontal, are they ever going to intersect? No. What do we call lines that don't intersect? Parallel lines. Okay, so this line and this line are parallel. Your line of sight acts like a transversal. What kind of angles are these two? Alternate interior angles. What do we know about alternate interior angles? They are congruent, right? So, if you have somebody standing up here looking at the same item or same object that you are, right, then your angle of elevation and angle of depression should be the same, right? So that's what we're going to write underneath here, okay? The angles of elevation and depression between two objects is the same. Okay, and that should basically be what our summary says. So, angles of elevation and depression are equal angles between two objects.